The Shearwater Wind Farm is in a very unique position with relation to Northern Ireland, and I will explain this uniqueness and explain the parameters and the dimensions of the wind farm and where the power will go to, and what we think the resulting benefits of this particular project and the projects that follow it will have on Northern Ireland. So I'd like to start off with a somewhat complicated diagram, but it's very central to the Northern Ireland wind industry. I believe so anyway. This shows the yield from the UK wind fleet, total wind fleet, both onshore and offshore, but the majority of the wind turbines that are generating this power are located in the North Sea. And this is the record for the last 2 years. And it shows the number of hours each month that the yield from the total UK wind fleet is less than 15% of its generation capacity. So this is basically a wind fleet of 25 gigawatts. So imagine a 25 gigawatt power station. And for certain periods of time, it only produces 15% or less of its design capacity. And we can see from this, the vertical axis is hours in the month. There are between 720 and 744 hours in the month. And we can see that for the periods April to August in each of 2019 and 2020, for those 4 months, the output of the UK wind fleet was considerably less than its design capacity, somewhere in the region of 40 to 50% of the time. The output was 15% or lower. That's 3.75 gigawatts. Now, just to give you an idea, the average demand, UK demand during this period is between 30 and 36 gigawatts. So this is a generating facility designed to meet between 30 to 40% of the UK's needs, and failing to do that during these 4 months. And the reason for this poor performance is the presence of high pressure systems, mainly continental or from the south and the east, high pressure systems, which are more frequent and persist for longer over the North Sea, and as a result of the weakening jet stream. And so they're not so easily dislodged. And if we go to the next slide, we'll see these are the weather patterns that give rise to those poor performance data you saw on the previous slide there. Each of these occurred during that period, and you'll notice 2 things. You've got a cell of high pressure over the North Sea, which basically reduces the output of the wind farms considerably, but you can also see the influence of the westerlies on the west side. They come up against this high pressure system, they get stuck, and in most instances, the weather system is deflected to the north, depending upon the strength of the high pressure system. And this is very important for Northern Ireland because you can see where those isobars are closer together, the winds are stronger. Where they're wider apart, there's very little wind. And of course, you see off the north coast of Ireland there, they're very close together. So while the North Sea is dormant, the wind is blowing off the North Ireland coast and is capable of generating a lot of electricity. We go to the next slide, we see this is where our wind farm is located. And if I could take you to the top corner, there you have Malin Head, Londonderry, the Northern Ireland coast, and this is the island of Islay off Scotland. We are in fact in Scottish waters. This stepped boundary here is the boundary between Irish and UK waters. It's actually demarcating oil and gas blocks, which were agreed many years ago. That hence its geometric nature. We're right up against it. The blue areas indicate shallow water suitable for jackets, and the white areas indicate deeper water suitable for floating. It's a mixture here, and as we go through the presentation, I'll explain why it's a flip of the coin at this point in time, whether we opt for jackets or floating at this stage. But this is the area. It's quite a large area. We believe this area is capable of producing between 3 and 5 gigawatts. There's also excellent area on the Irish side of the border as well for development. So this is quite a large wind farm area, which to date hasn't been recognized. But because of the problems with the North Sea, we anticipate very rapid development in this area between now and 2050. Where does the power go? Well, unfortunately, the power can't be landed in Northern Ireland or connected to the all-island grid. The simple reason is that there isn't the capacity. The closest part of the grid in the Londonderry area has an available capacity of around 60 to 90 megawatts, and this is a 1.1 gigawatt facility. So really the power has to go straight to the UK grid. It can't be brought to Ireland and then re-exported. The obvious location would be to bring it to Scotland, but Scotland has this part of Scotland, southwest Scotland, is heavily congested in terms of transmission capacity, and they're looking at building new connectors from north to south. So if we were to land the power in Scotland, it would just mean another connector would have to be built. So why bother? Why not just take the power directly to where we want it to go? And in this case, it's the point of Wilfer on Anglesey, where the nuclear power station recently closed a few years ago, and where there's capacity in the grid to take that power to the Liverpool-Manchester demand centre. It's a distance of 325 kilometers directly, but we have to go around obstacles and problems on the seabed. So we anticipate up to about 350 kilometer distance for this. This is an HVD system. So we take the power from the wind turbines, which is AC, convert it to DC, transmit it to Wilfer, and then convert it from DC back to AC again for introduction into the UK grid. The next slide. This is an offshore converter station, and in the Shearwater 1 wind farm, this converter station will receive power from the wind turbines, convert it to direct current, and introduce it into the cable. So this will be located north of Ireland. We anticipate and hope that these offshore converter stations will be built at the Harland and Wolff Yard in Belfast. And we anticipate that that yard and the surrounding area will also contribute to much of the heavy industry, particularly the foundation work of the wind farm. So it's quite a monster. This is an 8,000-ton monster, and the Harland and Wolff Yard is capable of building about 3 of these at a time. It's one of the few places in the world that has this capacity. Specifications for the wind farm. Well, I've mentioned there's at least 3 gigawatts of fixed wind generation. The rest is floating. We need quite a large seabed for this wind farm, for the simple reason the turbines are extremely large and we don't want them to interfere with each other. The average wind speed is well in excess of 11 meters per second. This compares with about 7 to 8 meters per second for the North Sea. Water depths in the 40 to 48 meter range, so suitable for jackets, but that doesn't imply that it's easy to build jackets out there because of the available weather windows. It could prove very expensive. That's something we're looking at. The size turbine we'll be putting out there is 15 megawatts. This will be built towards the end of the decade, so that will be the standard offshore wind turbine size. I'll skip the metrics there. The wind farm capacity is 1.1 gigawatts, or 1,125 megawatts. Capacity factor of 65%, so it's quite high compared to the 45% for a wind farm in the North Sea. But if I can just draw your attention to this metric here, which is the wind farm generation efficiency. This implies that the wind farm will produce 6,583 megawatt hours of power per year for every installed megawatt of capacity. Now, this compares with the average UK fleet of 3,916 megawatt hours. So it's basically 40% more efficient than the existing UK wind fleet in terms of being able to generate power. So we'll go to the next slide. The economic benefits of this. As I indicated, Belfast will be the primary engineering centre for this wind farm, with the offshore converter station construction, the foundation work. If we opt for more floating rigs, there'll also be a requirement for assembling those and manufacturing those rigs, and again, Belfast is well suited to that. There's also, as I indicated, 350 kilometers of cable to be laid, and we'll need a base for that. And then throughout the operational life of the wind farm, there'll be maintenance to be done on both the wind farm itself and the HVDC transmission system, the cable. Now, there's one unique feature of this wind farm, and that is that it lasts for 60 years. The reason for this is we're combining this wind energy with the output from a small modular reactor plant at Wilpher, and that has a lifespan of 60 years. Now, most wind farms last for 25 years. So what we're doing with this one is we are planning for a complete refit between years 25 and 35, where each wind turbine generator will be completely refitted, new blades, perhaps new generator, whatever needs replacing to give it the lifespan of 60 years. So this is the first 60-year wind farm planned in the world that we know of. So very, very exciting development. And of course, that refit again implies a fair amount of support from the Northern Ireland economy. In terms of engineering support, the main centres will be Londonderry and the Marine Engineering Centre of Killybegs, which is the closest to the wind farm. There was obviously the EIA and public consultation services required because Northern Ireland is the closest location to the wind farm, and of course there's a community fund which we have to pay into, and that fund will benefit those communities in Northern Ireland. There was also a fair amount of climatic analytical data processing, and a lot of wind, which then leads to the actual wind farm design, and we anticipate much of this will be conducted in Ireland. The timeline for the project, we're pretty close to kicking off with it. We're waiting for the Scottish Government to take a decision on this seabed. We hope it's an easier decision for them because the power doesn't come to Scotland, so they don't have to struggle with how to transmit it and export it to England. That's all sorted out. But so we're hoping for a decision this summer, after which we'll then appoint both the wind farm developer and the HVDC system developer. We have people lined up for this already. And following that, the EIA and public consultation teams will need to be activated pretty quickly. One of the key features of this, this development exercise is putting a LiDAR buoy out into the wind farm site and recording the wind, the waves, marine animals and bird life, etc., at the site. So that's a very exciting development. Despite this possibly being one of the best wind farm sites in UK waters, we know nothing about it. We haven't been recording information here at all. So we really do need to start to do that at a very early stage. We anticipate planning applications being submitted by 23 and start of construction around 24 to 26. We'd like to commission the transmission system by 2028, with the first power being delivered to Wilpher that same year. And hopefully, if the weather's kind to us and there's not too many delays, we may be able to commission the entire wind farm in around 2029. And that, ladies and gentlemen, brings me to the end of the presentation. Thank you very much for your attention.